Okay, last time I solved a word problem regarding a spaceship with this formula here. And the thing to keep in mind here is this. Okay, we have a formula. We're going to be given a word problem. Basically, we're just reading the problem, trying to figure out what numbers to replace variables with. And even before all that, when I see ln in a formula and no other things, I know that I'm going to have to isolate the ln term, and then I'm going to have to take that and the other side and use a base e. So this will become the power of base e, because e and natural log as an exponent will cancel, and I'll get these variables down into the equation where I need them to be. All right, let's look at this next one. I'm going to do it now. This time it's kind of the reverse. I look at this formula. This is Newton's cooling law, and we don't need to know a lot about it, but it's good to know some basic stuff here. When I read the problem here in a minute, TR, in our case, would be the air temperature, or it could just be the room temperature, the temperature around the object, okay, when things are happening. T0 is the initial temperature of the object. So I've got a piece of metal, let's say it's got a certain temperature on it, and then I'm going to move it somewhere where there's going to be a new temperature, and that's going to act on it. X is the number of minutes that the new temperature is acting on the object. T will be the current temperature of the object at time X. And then finally, K is a cooling rate. That's a constant, and it could vary depending on the item. Okay, that's the equation and kind of understanding it. Again, we don't need to know a whole lot about it. All we need to know is I got a bunch of variables. I need to be given a bunch of values. I plug them in. I solve the problem. What makes it a 5.5 type problem is this. When I see E and no other things, I know that I'm going to have to isolate E, and then I'm going to have to take the natural log of both sides. And natural log, since it's log base E, and this E is a base, will cancel, and I'll be able to bring my variable down and solve the equation. Okay, so they're actually very similar, and I'm only going to do one word problem, because pretty much all the application problems up to this point involve log, natural log, or e raised to a power. It's very common. Technique's the same for all of them. But here's the specifics on the one we're going to do. So I got a wet surface of 47. That's my starting temp. So T0 is 47. It's placed in a 5-degree freezer. So now I'm subjecting it to an air temperature or a room temperature, however you want to think of it, at 5 degrees. So TR is 5. So I'm just replacing variables with numbers. I want to know how long, so I'm solving for X. I know what K is, it's given, and it would need to be. And what does T equal? T is the temperature I'm interested in. I'm interested in when it freezes. Freezing is 32 degrees because we're looking at Fahrenheit. So again, when I look at an equation like this and I see an E, I know isolate E, take natural log of both sides. So let's do that. Bring the 5 over. Subtract this. So I've almost got E isolated. I've got to get rid of that. Divide both sides by 42. Now I want to take the natural log of both sides. And again, since that's base e and natural log is log base e, the bases match, so I get to cancel those. That you can do with your calculator. And then finally divide both sides by minus 0.12 and solve for x. 36, and we'll just round it to tenths. 36 minutes until it freezes. So again, between the example I did last time and this one, that's pretty much all the application problems up to this point. And the technique is the same. Isolate and use whatever rule you need to. Now we'll look at that one last. Let's look at these real quick. I'm not going to solve these, but we've worked on enough problems now, and hopefully you've done enough homework to where you should be getting a feel of looking at an equation and figuring out what to do. So when I look at something like this, I need to get these solved, but they're up in the exponent, so they're trapped. But when I look here, these look similar. I can make like bases. That's 10 squared, that's 10 cubed. So if I get a base of 10 on each side and use the rules of exponents, for example, this would be 10 squared raised to the x plus 2. That would be 10 to the 2x plus 4. Anyways, get like bases, set the exponents equal, and just solve that. Here, I have exponents or bases that are the same, but I don't have one base on each side. But again, I can do that. Use the properties of exponents to combine these. So when I have the same base and I'm multiplying, I can make it just e and I add the exponents. Over here, I can multiply this in, so I have e to one exponent. Now I would have just base equals base, set the exponents equal. Similar to this. Same thing here. Here I'm looking at logs. Well, I need to work this one of two ways. I can either combine these logs, so it would just be 5 times x minus 1. And then once I have log on each there, I could do the power of 10 on each side, and then that would bring this product down, and it would equal 10 to the 1, and I could solve that. Another option here, figure that out on your calculator, subtract it from 1, and then raise 10 to that and 10 to that, whatever that number happens to be. So again, I see log, I know I'm going to use a base of 10 to cancel it. Okay, what about this one? Well, this one's a little bit trickier. I look at this, and unlike these, you can't get these bases equal. It's not going to happen. I can't do a whole lot here with bases. However, I could use log or natural log, because what you're looking at here is if these weren't there, natural log of 2 or log of 2 and likewise natural log of 3, I can find those on my calculator. So take the natural log of both sides in cases like this. That's a way to get these out of here, because let's just look at the one side. Because you can take and move the exponent out front. Using the properties of exponents. And in this case, log properties. So what you can do is take the natural log of both sides, move this out, move the x out front of ln3, and then you'll have things that you can figure out on your calculator, and you'll just have numbers times x's on each side. So with something like this, you might want to take the log or natural log of both sides. Here, we got a problem. I can't, the problem is the bases are different here. So if I want to put a base of 3 here and here, that's great. This would cancel, but this won't. There's no way to undo this. So when you have logs with different bases, think base change. So I'll just look at the left side for you. The left side would look like log x over log 3. You can see where this is going. Log 8 over log 2. Now you have a bunch of logs you can figure out on your calculator, and all you'll have is log x. So when it's all said and done, log x equals whatever all these other logs come out to when you multiply and divide. And then again, to undo log, which is base 10, take 10 to each of these powers, and you'll be able to solve it. So base change is your starting point when the bases don't match. Something like this, okay, this is where you have a problem. That's a regular exponent. This is a e to the x. We got a mix of things going on here. You could have a natural log and e to the x all in the same problem. Those are mixes of things. If you notice here, logs, bases with exponent, just numeric, logs, all e's. You can get the same base here. Problem here is you got a variable as a base. Here you have a variable, but it's with e. This is a mix of things. So you can mess around and try to solve these, but generally speaking, when you see something and there's a mix of items in the equation, you can't solve it. It has to be done with software and looking for the intersection of the various graphs. So we had an example of that in a previous section. Finally, there's this one I thought I would work real quick. I found this. This kind of sums up a lot of stuff that we've learned, even going back into previous chapters. So the thing is, when you look at this, we can't really combine these things. I can't get just an e here and an e over here. I got this 4 in there, and they're multiplied by things. It's getting kind of messy. So what do you do with this thing? Well, take a look at this. These are the kind of things you need to watch out for. Doesn't this look like 3x squared minus 4x minus 4 equals 0? That would just be a quadratic equation that we dealt with before, where you factor, set the factors equal to 0. And in fact, if I use the rules of exponents here, and I rewrite this as this, okay, remember, e to the x squared is the same as e to the 2x. Now you can see it. Let's let u equal e to the x. So we're using a u substitution here. Okay, this will factor. Now we're going all the way back to that factoring chapter where when you have something other than a 1 as the leading term, you have to multiply the n terms. And then what you're doing is looking for factors of that number that adds up to the middle number. Well, 3 and 4 is either going to be 1 or 7 if you're adding or subtracting, depends. What about 6 and 2? If I put a 6 and a 2 here, and I want a negative, so let's make the bigger one negative. Okay, minus 6 times 2 is minus 12. Minus 6 plus 2 is minus 4. Those are the factors we want. So you replace minus 4 with these two numbers, which are the same as minus 4. So we've put these two in here. And again, if you remember, this was our grouping technique because it produces 4 terms. So you group first two, last two. 3u comes out here. Over here I can factor out a 2. And then again, if you do the grouping correctly and all this works, you'll always get a matching factor here. Factor that out. And what's left is 3u plus 2. And then to solve it, set each equal to 0. So if that's 0, u equals 2. If this is 0, I would subtract 2 and divide by 3. That'd be minus 2/3. That's u. Now, since u equals x squared, and I want to, or e to the x, and I want to solve for x, I got to put that back in for u. So sub it back in. Let's start here because remember e is 2 point something. That's a positive number. You cannot raise a positive number by any exponent and make it negative. So we got to throw this answer out. However, here, and we talked about this before, when I have e and I want to get the x out, use a natural log. Again, because that's log e, that's a base of e, that's a base of e raised to a power, they cancel. So x equals ln2, which is approximately 0.693, and that's it.